Hello everyone, welcome back to your channel Physics with Oliver. Please like, share and subscribe. Today we will discuss another new problem. Okay, if you have not subscribed yet, then please subscribe the channel. You will get regular videos in this channel and we will discuss different numericals from physics. Okay, let's start. At first, read the problem. An electron of mass m with an initial velocity v vector v0 I cap enters an electric field E vector that is equals to minus E0 I cap at time t equals to 0. If lambda naught is its de Broglie wavelength initially, then its de Broglie wavelength at time t is. We have to calculate the de Broglie wavelength when time is equals to t. Okay, we all know the formula of the de Broglie wavelength, that de Broglie wavelength is equals to h by p, where h is the Planck's constant and p is the momentum, right? We know momentum is equals to mass into velocity. So at time t equals to 0, the velocity was v naught I cap. So from here we can write that p vector at time equals to 0 is equals to m v naught I cap, right? So here from here we will get the momentum is mv naught. So de Broglie wavelength at time t is equals to 0 is equals to h divided by mv naught, and this is mentioned as lambda naught. So lambda naught is equals to h divided by mv naught. Okay, this is given. Now it is said the particle, the electron is in an electric field, enters in an electric field, where the value of the electric field is A vector is equals to minus E naught I cap. At first we have to understand what is the definition of the electric field. The definition of electric field means the force experienced by the unit charge. Okay, suppose in this region the value of the electric field is E naught. That means if we place a unit positive charge, that means if we place a plus 1 coulomb charge in this region, this plus 1 coulomb charge will experience the force E naught. Now from unitary method you can say if plus 1 coulomb charge is experiencing the force E naught, then we can say that q coulomb charge will experience the force q E naught, right? From unitary method. So what is the definition of the electric field? The definition of the electric field is the force experienced by unit positive charge is known as the electric field of the region. That means if we say that electric field of the region is E naught, that means plus 1 coulomb charge is experiencing the force E naught. So from here we can also calculate what the force experienced by the other charges also, right? So here the charge is given electron. Electron means the charge is equals to minus E and the electric field is this. So from here we can say the force experienced by the electron is q E vector, and the q of the electron is minus E and E vector is minus E naught I cap. So from here we can write E capital E naught I cap. This is the force experienced by the electron, right? Okay. At first we have seen the velocity was u, that is equals to v naught, and now the charge is going through an electric field, and due to that there is a force which is experienced by the electron, right? So if we apply a force on a moving body, then the velocity of the body will increase. So the final velocity will become something different, suppose v1, and the force which is applied is E naught I cap. So we know that force is equals to mass into acceleration. So from here we can write this is equals to this. So from here we can know that acceleration is equals to E by m I cap. So here the final, we all know the formula of the final velocity v equals to u plus ft. We all know this formula, v equals to u plus ft, where v is the final velocity, u is the initial velocity, f is the acceleration, and t is the time. Here the final velocity is v1 cap and the initial velocity is v0 I cap, and the acceleration is, this is the acceleration, we can write it by a or f, any one. So the acceleration is E by m I cap t. So from here we will get the total velocity is v0 plus E by m, sorry, E by m t, here I cap. This is the final velocity, right? So from here we can write the new de Broglie wavelength is, that is lambda dash, this is equals to h by p dash. P dash means momentum, this is the new velocity, so the new momentum will be mv1, so we will multiply a m here, so h divided by m v0 plus EET by m, right? So we can write that lambda dash is equals to h divided by m v naught plus EET by m. Okay. So here it is asked, if lambda naught is the de Broglie wavelength initially, then the de Broglie wavelength at time t is. So we can take common mv naught from here. So we will get 1 plus E naught t divided by m v naught, right? So we know this is the lambda naught value. So we can write lambda naught divided by 1 plus E naught t divided by m v naught. This is the value of the lambda dash. So this is the final solution. I hope you can understand this. If you have any doubt, you can ask in the comment section. Thank you. Please subscribe.